Right, it's Mick Williams. We're going to look at SSH, or Secure Shell, operating between two Ubuntu machines. So using OPENSSH at the core of that. We've got two machines, the Secure Shell client on the left, which is at .232 in the address form, and we can see the Secure Shell server on the right hand side, .233. User is Ray. In the server, we're going to have to edit the /etc/SSH/SSHD or daemon. There's a file we could also configure on the client side. Just take the D off that, and we've got the /Config. So we need to do the config files, particularly that one on the server. You'll see that for both, sort of perched underneath the cloud there, is this reference to the home directory, that's the squiggle, and .ssh, which is a directory. And then within that directory, we're going to have things like known hosts as necessary, or as we can see here, authorized keys, which is what we're going to play with. So let's get in there and have a look, and we'll start off by looking at the server. So here we are on the server. Let's have a look and see what we've got, see where we are. So we're in the home directory for user Ray, and if we have a look at Ray, we can see that as ls-al, we can see that we've got a user there, we've got a directory there. We can see it's a directory. It's got permissions 700, so it's got read write executable for Ray, but it's for everybody else. It's set as not available, so obviously the local user is the only one that can use that. So what's in there? So if we're going to have a look into SSH and do an ls-al, we can see all we've got in here at the moment is known hosts. If we were to cat that known hosts, we can see that it's actually blank at the moment, as I've removed those hosts. That's people that's known in previous connections. But we're effectively going to have a look at setting this up as the server. So as far as the server side is concerned, the main area of interest for us is in /etc/SSH. If we have a look in here, we see there's a number of files, some of which are keys. So if we actually have a look, these are actually the host keys. These are generated when this is established. So what we can see here is when it's installed. What we can see here is all of the keys. So we can see as a key pair, there's the DSA keys with the private one and then the .pub for public. And then we've got the ECDSAs, that's the enhanced ones. Then we've got here again, oops, we should pick the pair out, there they are. And then we've got the RSA ones, okay, down here. All right, again, as the private and public key pair. So that's the ones the actual server will be using, whenever it's actually involved in any sort of key exchange. Right, the things that we're also interested in here are the SSHD, that's on the server side. The SSH config would be on the client side. So here we can see SSHD config. So that's the file that I'm actually going to go after. So we'll do a sudo nano and we'll go in and look at that SSHD _config. So as we come down through, what we can see is that it's actually set up currently to be listening on port number 22. We can change that. We'll leave it as set for the moment. We've also got the protocol level 2, and older machines may be out there at protocol 1, but really we should be using protocol 2. If you want to see some more details on that, just do a man against SSH, and you'll see that detailed in terms of how it establishes the session, which is opposed to how we're doing it. You can see the host keys are mentioned in here as well, so we can see the RSA key, the DSA key, and so on. So that's the 4 sets of keys, if you like. And then we can come down through, see the server key bits. Now the other bit that I'm particularly interested in is things around X11, and also in terms of whether or not we can use passwords in order to gain access to the system. So scroll down a little ways and we will find it. So we can see here, password authentication is hashed out. So at the moment, you'll be able to use passwords to gain access. What I'll do later is I'll come back and change that to no. I know it's hashed out at the moment, but that's whether the default is at the moment. Passwords will be accepted. So X11 forwarding is also on. That's a choice. Okay, so you can have X11 on or off, and this is pretty much the default that's set in here and there's pretty much not much else that I need to set at this present time. So bearing in mind, the only fields really I'm going to set is password authentication. So I'm going to take that hash out at some point. Could do that now, and then come back later and change that to no. And then as we scroll back up, the other sort of main area of interest is the port numbers. We might want to change the keys and therefore have to reference them from this file, but otherwise it's the port numbers and the protocol. So leave the protocol unchanged and maybe add port numbers in. So you can have multiple ports. So we could add another port in here, Control X, yes to save, and hit return. And that config file has been changed, but of course you need to then make sure that it's actually been taken. So SSH is the service, and we can do a restart against that service. If you prefer, you can do the / etc / initd. Okay, so that gives you something back. But also, of course, you can also check the current status. So we can see what's actually happening here in terms of this device is listening on several ports. So SSH is up and running, and it's actually listening on those 2 ports. At least that's what it tells us it's doing. So let's have a look, in fact, and see if we can see that on the other end. So if we go in onto the other device, which is our client, let's just have a look and see if we've actually got Nmap running down here, which would be a useful sort of tool to actually have a look and see if we can get it sort of working. So if we have a look in the apt cache, well, actually, first of all, let's do an apt list. So let's do that. Sudo. Well, that didn't take very long, so we're in, and let's see. Ignore that in the background. Need to put some more memory in. So there we go. Nmap's in, so let's have a look see what Nmap does in terms of telling us about the other end. I'm not doing anything special here, apart from not typing it correctly either. So you can see it actually picks up that both of those ports are indeed open. We can also do Nmap, of course, against localhost. See what this is doing. And that's actually got port 22 open on the localhost. So there we go. Might want to close that down. Okay. In terms of which way we want to establish communication between these 2 ends. So remember, this is the client. So we want to establish a connection from the client through to the other end. So what we need to do is, of course, we'll have a look around and see what we've got in terms of files. We've got an SSH. No, we haven't got a .ssh, so let's make one. So let's make a .ssh. We need to change its permissions, so we make it a 700 against that .ssh, and we can see that now. And again, we'll grep that .ssh, and we can see the permissions are set. Good. So let's go into that directory, and of course there's nothing here. So what we're going to do first of all is we're going to generate some keys down here. So we'll use SSH Key Gen. We'll do that as -t RSA, so I've set the type, and I'm going to set the length 4096. So this is where it's going to put it. It's going to put it in the user's directory, so that's /home/ray in this case, in .ssh, and it's going to store it as the, well, that is going to be the private key. In fact, there'll be a public key as well, under ID_RSA. Fine, I'll accept that. I'm not going to put a passphrase in, and it randomizes it and generates the keys. Well, has it? Let's have a look. Indeed it has. So we have the keys in place at effectively the client end. Now remember what we've got set at the server end. So if we look at the server end again, so just go into there quickly, and again if we have a look and see what we've got set up here, that's in /etc /ssh. If we go home and into .ssh now, and we have a look in here, we've only got the known hosts, and again if we actually have a look at that, that's empty. Right, fine, good, okay. So that's all we've got in place up there at the server. So back to the client. So the thing that we're going to do here is we're going to shove that ID across an SSH session into the server. All being well, of course. So here we go. So what we're going to use is secure shell. We're going to do a copy of the ID, and we're going to send that across to Ray at 192.168.1.233. So are you sure you want to continue? Yes. And we need the password. Well, the password is Ray. Very secure. Now log into the machine with that Ray. Check to make sure that right. Okay, let's go and have a look. So if we pull up the server end of the equation and we have a look in here, we can now see an authorized keys folder is in there. Good. And there it is. So that was a little bit cute in the sense that we've just used secure shell to create that connection. But of course that means that secure shell is, well, insecure because we're using passwords. We prefer to use keys. So let's go back and change that. So it's sudo nano, and we're going into /etc/ssh/sshd_config. So that's the one we want to edit. What we want to edit, of course, is where it talks about authentication. So we're seeing this section here, and where we wanted to say essentially we do not want to use passwords. So we're looking for that password authentication. Remember, I removed the hash in front of it. So as we scroll down, we should see it coming down here. See, things like permit empty passwords should always be set to no. We're going down to here. Here it is. The password authentication here. We'll set that now to no. So Control X, yes, and hit return. So that's now in, but of course we need to engage that, so we can go back up through our list of commands that we did before. We can do a restart against that. Okay, so that will now take. All right, let's go back to the client. So back to the client. So the client side of the connection now, we want to prove that that connection is actually up and available to us. So we want to make a secure shell session through, and of course it's going to be using the authorized keys that we have available to us. Okay, so there's the keys that are actually set within our .ssh folder. So let's give that a whirl. So we're going to go through, we're going to do SSH, and we're simply going to go through to Ray at 192.168.1.233. So that's the connection that we're going through. There are other options we could put in there. We could have put -X in there, that's -X to support X11 forwarding. We could also do -P in there so that we could do things like identify the particular port. Default port, of course, is port 22. So let's give that a whirl, and away we go. So what we can see here is then, in the sense of the feedback that we get in terms of the actual connection itself. So if we actually see where we are and essentially the machine that we're actually on, so that, because of course this is a secure shell session, or should be, through to the remote machine. So if we do an IF config, and that's that ENP3S0 thingy, oops, wrong way, 0S3, that's what I don't like about it. We can actually see that we're on the remote machine. There we are. Of course, you could have done this sort of all the other bits and pieces as well. Who-AL, useful, because we can see who's logged in. We can actually see where we are at the moment in time, because we are /dev/pts/18. So this is our connection here, look. Okay, that we've actually got coming through. That's all very well and good. So this is the sort of thing that you'll sort of interrogate and find out about sessions. Of course, with the -AL, you've actually got the actual here. You've got the process IDs. So, you know, if you was to do a PS AUX and then grep that through SSH, you'd see the SSH sessions in there as well. And we should see some corresponding, here we go, there's the corresponding number there, look, 17987. So all is good. Of course, what we could do is we could on this, well, remember we're on the server end of the connection now. There was no prompting for passwords. This should be a secure connection between the two. So what we'll do, we'll exit out of there. Okay, we can see the connection is now closed. And again, we can do an IF config, and we can see that Indeed, we're now back to 232 opposed to 233. So one of the things that we could also do is we could have defined against this particular username, what we could do is we define the port number. And the port number we could say is, you know, a different port. So we could go that 2222 that we had before. Okay, so let's go and do that. This should establish the connection as before. So if we go and have a look and we do a sort of a sudo nano /etc/ssh/sshd, and we put the password in, it's always confusing when you've got the same user at both ends. Okay, you can actually see this is the modified version. Look, we've got the port number there, port 2222 and port 22. Let's put a hash in front of port 22. Control X, yes, and return. Then remember, let's do the sudo service SSH restart. Let's exit from this session. Let's try and do a port 22. Of course, we don't need this. We could just take the -p away altogether. And we can see that the connection is refused. Just to prove that as well would be 22. The port connection is refused. But if we do it against 2222, the port connection is accepted. Okay, so again, U-AL, and we've got the connection in there, TTY, to see which connection we are. Good. There's lots more that we could do, of course, with regards to configuration-wise. So let me just exit from there, which will close the connection down. Yeah, do who-AL here, and you can see that it's us logged into the local connection. Yes, TTY now tells us that we're on PTS 17 on the local machine. So there we go. Right, good. Okay, let's see. What can we see with Wireshark? Just clear that. Okay, make sure we're not anywhere. Good, clear that. Okay, let's have a look then. Right. Right, so let's just pop across to the server end and let's get Wireshark running over here. I could ignore those, it's fine. Just if I go full screen on this, why not? I want to capture filter in here, so we're only looking for particular ports. So we'll look at TCP port 2222 because that's the beastie that we're after, and we're looking at that particular port. So you should click on there first and then put our filter in to, I'm just selecting from the drop down menu if you've got one there. Okay, and away we go. So in we are, nothing happening at this moment in time, which is good. So if we go to the client end of the connection, so if we go to my bright spanky new one over here, let's just come out of there. And here, of course, what we were doing before was we would actually secure shell connections through. We had to put the port number in because otherwise it wouldn't work, and we had to specify the host and their IP address. Okay, so the username and the IP address of the particular server. So all being well, that should work. Now what we can see here is the authenticity of that can't be established. So are we going to accept it or not? So yes or no. So yes to that. So we permanently added that to the list of known hosts. Permission denied against our public key. Interesting. So what we have to do is make sure that we've got things sort of set up correctly. Right, so I'm going to go from the client. So just need to go in. If we actually have a look at our history, we should see something of the correct ilk, which is this beastie here. That's what I want to do. So let's copy and paste that in. That's a bit better. Here we go. So we've actually made the connection through to the far end. And again, if we look at the server end of the equation, we should be able to see that sort of happening. So we'll just come out of there, remember to exit. Connection is closed. Let's just make sure that Wireshark is ready. So here we are on the server end. We can see we're actually looking here again for that TCP port 2222. So there's nothing happening here. There's stuff happening in the background, but of course has been not captured because you've got a capture filter looking for that specifically traffic. So if I bring in my first Ubuntu machine, and if we take that off full screen for a moment, just drop that down to the side, we should be able to repeat the last command. So we should be able to come in. So if we do that, we should see some traffic hackling away in here. Now, as far as Wireshark is concerned, it doesn't know what it is, so right click on it. Right click anywhere. In fact, if we're going to the right click onto there and then decode as, and then what we're looking at here is that it says port number 568. No, that's not the one I want, it's the other one, port 2222. That's fine, just drop it from the drop down menu and then scroll away down. S will help, so just hit S, it will come down to the right sort of area. Scroll a bit further down and we should find ourselves in the territory of SSH. There it is. OK to that, and lo and behold, it looks like a proper establishment using TCP. There we can see the exchanges going on between the client and the server before it's finally encrypted down here. So you'll see all the sort of Diffie-Hellman stuff taking place up here before we actually then get to the proper key exchange. And then after that, sorry, here we go. There's the Diffie-Hellman key exchange, apologies. And after that, we'll end up with encrypted packets going down through here. So again, this reinforces the fact that we are actually using port 2222, and that's certainly true when you have a look at the transmission that's going on here between the client and the server. There's the source port. So if the source port is coming from the source IP address of 233, then of course that's coming from the server. Indeed it is. So we can see the normal sort of exchange taking place down there. So here we can see we've got that sort of server and client key in it. So what we're seeing here is a sort of offers in terms of the algorithms that they can support. Then we'll see the Diffie-Hellman exchange. So the exchange here is using half key information in order to then establish a session key, and then that session key is then used to secure the connection. So the first part of this connection, in fact, is then the exchange of the secure keys themselves in order to formalize the relationship between them using well, effectively the authentication phase. So the authentication phase actually occurs down here in these encrypted packets, but of course we can't see that because that essentially is hidden from us, quite rightly so. So that's the initial Diffie-Hellman exchange, and then followed up effectively by the sort of key exchange to authenticate the user, and of course we're still maintaining a secure connection all the way through. So everything after this is encrypted, including the exit. So if we drop out, in fact, if we control M, in fact, if we hit up the top of the screen here, hit this icon here, so you're on the last packet, so it'll scroll live with that last packet. And if we just control M that, we'll see that this particular packet should be marked. It says, hopefully. Oh, well, that doesn't seem to want to do marking. So there we go, right click and mark. Control M it was, but there we go. There we go, better. Didn't like the Control M for some unknown reason. We've got it scrolling real up. Right, perfect. So if we then do the exit, so complete that command, we should see, whoa, off it goes, and the connection is closed. So we'll see the FINAX going on down here. The session is closed. So everything about that session was encrypted. So you can see the keys that are going through very much as part of that session, and the session is now closed. Excellent. So I think that's where we'll leave it. There are other configuration that we could have done, of course. This is now, bearing in mind, we're actually on the client end of the connection. So if we have a look down here, we can see that this is definitely my client. I've tabbed that so I know where I am. And if I go into cd/etc/SSH, then of course in here, if this is the client end, I don't need the SSH config. What I do need is the SSH config. So I could use that and then sort of pre-configure the elements within that file. So again, sudo nano, and then we're looking at that particular file, which is SSH. So we need the underscore character, and away we go. So we've got SSH. Ooh, there's a lot of stuff. So it's C for config, and there we are. Put the really secure password in there, and this is the sort of stuff that we can actually start to do in terms of that SSH session being established based on the SSH config file.